Okay, I believe we're live. Hello everyone, welcome back to the second review of my lectures. This is going to be a whole series. You can see the series on my YouTube channel, going through the physics lectures that I have that I'm taking for college first semester. So, we are doing... Hold on, someone texted me, just give me a second. What time are you? Okay, I'll deal with that later. Okay, so we're going to continue. This video is going to talk about more about vectors. We're going to discuss the cross product, and we'll actually bring the vectors into some real physics in this video. Shouldn't be too long, but there is a lot to cover. So let's start. The first thing we're going to cover is the concept of base vectors. So what are base vectors? Base vectors are the most normal vector. The first idea of a vector that would come to your mind would be a base vector. The problem is there isn't one. There are 3 or 4 depending on the dimensions you're in. So let's illustrate this. So imagine we have our x and y, and actually we're gonna add another one for the z. So imagine we have our x, y, and z axis. You could see this as like the floor, if you wish. Like this is the floor, this is a wall, this is a wall, and we have the roof. So this is an x, y. This is a 3-dimensional plane, or box, or cube, whatever you want to say. So the base vectors are the most standard kind of vector. Let's increase my thickness a little bit, and let's draw the base vectors. So this would be one base vector. This would be another. Oh no, I'm gonna make this a different color. This would be another. And then finally, we will have the last one, which we'll make orange, I suppose. No. Let's go back. It needs to be right on the axis. Come on. We can do this. I believe. No, stop it. It has to be perfect. By the way, I am getting a pen, a stylus, so the drawing will get better. So these are our base vectors. The first thing that needs to be established is that they are all of length 1 in their respective axis. And yeah, they're all of length 1. They are all perpendicular to each other. I suppose this would show perpendicularness. And yeah, and they all have a name. So this one's name, the standard, the x-axis one is I with a hat. That's not a hat, that's like a big arrow. The x-axis is I with a hat. The y-axis is typically J with a hat. And the z-axis or z-axis is typically K with a hat. So these are all perpendicular. They're all, which means that they're orthogonal. So the base vectors are the set of orthogonal, which means they're perpendicular. They're all perpendicular to each other. Unit vectors, one for each dimension. So they all get their own dimension. They're all perpendicular to each other, which establishes our plane, our cube-ish thing in our current situation. So because they are all perpendicular and they are all of length 1, we could establish some rules about them. The first one is that I, the dot product between I and I. Well, let's remember what the dot product is. The dot product is the length of the first times the length of the second times cosine of theta. Okay? So, oh, sorry, this is the wrong color for I. My bad. I, the length of the first times the length of the second, well, that's 1 and 1, times cosine of theta, theta being the difference between the two angles. So cosine of 0 is 1. From our unit circle, we know this. So I equals 1. Similarly, almost like identically, J equals 1. And I hope you can guess what this is going. K equals 1. So they all equal 1. Furthermore, we have the opposite with respect to each other. So I dot J is 1 times cosine of 90. Cosine of 90 degrees is 0. So I dot J equals 0. And then we have, and that will continue for the rest of them as well. So we could have J dot K, or rather J dot K is also going to be 0 because they are 90 degrees, and that follows for all of them. Now there's some more. There's some more rules. We could have, in theory, I cross the cross product between I and j. So let's remember what the cross product is. So first of all, we know that the cross product will give us back a vector. That's like the rule. The vector will have a magnitude of the first vector times the second vector times sine of theta. Okay? And what's more, the resultant vector will be in the direction using the right hand rule. So you put your right hand by the first vector, you turn your fingers to the second vector, and the way it's pointing, the way your thumb is pointing will be the final vector's direction. Okay, so because of this, I cross j, so that's going to be 1 times sine of theta, theta being 90 degrees, sine of 90 degrees is 1, so it's 1 times 1 times 1, so it's going to have a magnitude of 1. And the direction, I hope you can understand this, is in the z-axis, because it's coming toward us. So if the x-axis is to the right of us, the j-axis is, if the x-axis is to the right of us, the y-axis is up, so to the right, and the y-axis is up, then the resultant of I cross j will be in the direction towards us, which is the z-axis. So I cross j is actually k, because k has a length of 1, and it's on the its orientation is on the z-axis. So that's very cool. And similarly, we could have I cross k. So what would I cross k be? Well, I, so we go on the I, and then we turn our fingers towards the k, which would mean that I have to go like this and like that, which means, hold on, yeah, oh my god, this is breaking my hand. So we're on the I, we turn our fingers towards the k, and we're facing down. The thumb is facing down. Yeah? Yeah. Wait, did I mess this up? I cross j, the thumb is facing up, which in my case is like towards me based on how I'm looking at this. And then I cross k. I really messed this up in terms of like my orientation. Hold on. What would k be? K would be like going down like that. But that doesn't work. Oh no, I guess it does. Yeah, I cross k would bring me like that, which would be in this direction. Hold on, this is all very confusing. Yeah, I cross j is going to be k. I cross k is, I think, negative j. I could be wrong though. If this is I and k is over here, then yeah, I think it's negative j. So this equals negative j. And I encourage you to really, the best thing you could use is a table. So use like the edge of your table as your x-axis. Turn it toward you, which would be your z-axis. We're going to make that your z-axis. And then you see that your thumb is pointing down, which would be negative j. Okay? That's the best I can do for you. Then we have, hey, I'm streaming. Just FYI, my roommate just walked in. Sorry, it's fine. You could talk, you can make noise or whatever, it's fine. And okay, fine. So then we could have I cross. What else do we have? No, we don't have any more I crosses. We did all the I crosses. So we could have in theory j cross k, which is going to equal, what would j cross k be? Well, let's use the right hand rule. So j is up, so let's put our right hand up, and k is toward us. So our right hand being up and our finger pointing towards us, that's I. That's just pointing to the right, which would be I. So let's make that I. J cross k is I. I think that's true. I think that I have that written. Yep, I do have that written down. And then we could also have j cross I. J cross I, which in this case would be, okay, let's do that again. So let's point our right hand up. Let's fold it in the direction of I. And we see that we're going away from us, which is negative k. So yeah, j cross I is negative k. Equals negative k. So you see how all these unit vectors are related to each other. Let's just do the k's now for consistency. So k cross, let's do j first. J equals, okay, so k would be toward us. We're gonna point our finger toward us, and we're gonna turn our hand toward us, and we're gonna go up. So k cross j is going to be negative I think. Yeah, k cross j is negative I. K cross j is negative I. Negative I. And then we could have k cross I, which I guess would be j just by how we're going. K cross, okay, so let's do k. So point the right hand toward us, cross I like that. It's going up, which is j. So that is j. It is equal to j. Excellent. Okay, now I want to show something. So first of all, we have j cross k over here. Over here, sorry, I want to make this over here we have j cross k equals I. Okay? And over here we have k cross j equals negative I. So you see that a cross b equals negative b cross a. Happy good. Hello. Hello. How's it going? Happy good. Welcome to the channel. I suppose you left already probably. I'm sorry, I'm not looking at the chat too much. So you see that, yeah, so a cross b equals negative b cross a. Like that, right? I hope that makes sense. All right, that is our introduction to base vectors. So very cool stuff, honestly, pretty cool. Sorry, I was helping someone with math not too long ago. Let's just erase all that. So let's move on to the next section. Let's talk about, now that we have these basic ideas of base vectors in this hat notation, let's talk about how we could represent vectors in terms of hat notation. So imagine we have a vector, and we call this vector A. We could describe this vector in terms of hat notation. So we've described it in terms of length times the length. Can I ask a physics question? Yeah, sure, go for it. Hope I can answer it. I don't know, but until he asks the question, I will continue. So we described it in terms of like its tuple notation, right? We have let's see if I can make the colors consistent. We have ax for the I-axis, comma ay. No, sorry, that was the k. Comma here, ay, a sub y, comma, and here we have a sub z, right? That was what we had before. We had our tuple notation. Now let's talk about another notation, which is hat notation. So we could do, instead of saying it like this, tuple notation, we could actually make the we could actually define a vector in terms of like sum. We could add up a bunch of different vectors. What vectors would we add up to get to a? We would say ax times I times the vector I, and ax would be a scalar, so this is scalar multiplication, plus ay. You're teaching PhD level physics while I'm just a 10th grade, haha. I'm not teaching PhD level physics. This is mechanics through calculus. This is freshman year physics. At least for me, it's freshman year physics. But anyway, no, this is definitely not PhD. Not even close. But that's not a question. Any object that has mass has inertia, but won't a moving won't a moving object stop automatically due to inertia? Does it break first law of Newton? I'm bad at inertia. Okay, so let's talk about what inertia really means. Sorry, we're gonna take a break from my physics lectures. Inertia means that, well, it could mean a lot of things. First, let's talk about what Newton's first law is. Newton's law says like this: if an object is in motion, something has to stop it. Otherwise, it will continue to be in motion. If an object is not in motion, something has to start it being in motion. Otherwise, it will continue to be not in motion forever. A great example would be gravity. If there's no gravity anywhere, imagine you have a rock. Let's say a rock. Imagine you have a rock, and it's in space, and nothing is anywhere else in the universe. It's just going to sit there. If you make another rock, they're going to attract each other by gravity, so they'll start to move. So that force, Newton describes it as a force. So the way he says it is, an object at rest will remain at rest unless acted upon by an unbalanced force. So it needs to have an unbalanced force acting on it, and then the object will start to move. Why does the force need to be unbalanced? Well, like this. My bottle of water isn't moving because I'm holding it up and gravity is pushing it down. So in this situation, I am balancing out gravity's force, and so the bottle of water is not moving. If I were to push with one finger more than the other, it would move to the right. But if I were to push equally in, it's not moving because my fingers are balancing each other. And I can push more with my right finger than with my left, and it will move to the left. So that's the basic idea of inertia. Now, won't a moving object stop automatically due to inertia? No, inertia is not a force. Inertia isn't a force. It doesn't stop or start things to move. So, yeah, your real issue is that you have a problem of definition. You think that inertia is the thing that makes something not move. in some way, but it's not. It's the thing that makes it hard to change the movement of a thing. So a big truck has a lot of inertia, which means it's hard to stop it from moving. If it is moving, it's hard to stop it. If it isn't moving, it's hard to start it. Like, it's hard to push. So that's what it means when you say it has a lot of inertia. The real physical word would be accelerate, which I don't like to use the words because sometimes it could confuse people, but a big truck is hard to accelerate. It's hard to get it to move, and it's hard to stop it from moving if it is moving. But inertia itself doesn't actually change the movement of an object from its situation. So a big truck wouldn't stop because of its own inertia. I hope that makes sense. I just went through a lot of things to try and clarify everything. If parts of it were confusing, let me know in the chat, but I hope I could help. Okay, let's continue with the review. So we could express a vector in terms of the summation of different vectors. So we have the first vector over here, which would be ax times I hat. And by the way, don't worry about being bad at inertia. It's a tricky subject. A lot of people get mixed up with it. Okay, so we have ax times I hat plus ay times j hat. So remember, both of these are vectors, right? This one's a vector and this one's a vector. And when you put them together, they make a new vector. And then if we also add, finally if we add plus az, you're giving me free lessons. Of course, I mean, that's why I'm here. I'm happy to help. But more than that, did it make sense? Tell me if it made sense. Ask anything more. Sorry, I'm bothering you, sir. There's no. First of all, no, don't call me sir. I'm not a sir. I'm Alicia. Just stop. You don't even have to say the Alicia part. Just sorry, I'm bothering you. I'm 19. Stop calling me sir. But there's no issue. There's no issue. I'm happy to take time. That's why I'm live streaming. Otherwise, I would record it and upload it. Like, I'm happy to interact with people. Just let me know if my explanation made sense to you. So plus az k hat, essentially. Okay, great. So ax I hat plus ay j hat plus az k hat. This would all equal the vector that we call a. So that is a new way of writing. Why do we write it like this? Well, you'll see. You will see right now, I think. So first of all, let's talk about how we would express certain things that we've established using this notation, shall we? So let's first of all rotate this page. Rotate this page about 90 degrees. I prefer working on it like a flat thing. Okay, so let's talk about how we could express some of the things. So let's talk about vector addition using the definitions, using this notation. Okay? So vector addition will look something like this. Vector A plus vector B. Vector A plus vector B. So what does that equal? Well, we had previously discussed vector addition as using the head and tail method. I don't think we ever actually did it tuply. But really tuply it would be ax plus bx comma ay plus by, right? That's how you would say it, like in terms of tuple notation. But if we want to do it in this new notation, which I'm actually going to just call straight up vector notation, or vector addition notation or whatever, if we want to do it in that way, we could express it as something different. We could say ax, here, I'm going to keep the colors because I like the colors. Okay, we could say ax times, wait, no, not times, plus. Ax plus bx times I plus ay plus by times k. That made no sense. I said k because I was working in yellow, and I register k with yellow now. It needs to be j. Ay plus by times j. And then that plus, now we're doing the case, az plus bz times k. So that would be our new notation for vector. And you can see we could use like, again, ax and bx are scalars. I was actually trying to figure out some trick questions by myself. Some of my friends discuss some weird questions. I was actually trying to figure out some trick questions by myself. Is this for class or something? Some of my friends discuss some weird questions. Yeah, friends do that. Was this like just a conversation that brought up? Like you guys were like, wait, inertia is this thing, doesn't that make it? But the point is, yeah, you just misunderstood inertia. Great. So, cool. ax plus bx times I plus ay plus by, that's a y not an x, times j plus az plus bz times k. Okay, so that would be vector addition. Now let's talk about like the dot product. We could also describe the dot product in this kind of notation, this vector notation. So instead of having a plus b, let's try, oh boy, let's try a dot b. So what would a dot b be in this notation? Well, this is weird. Yeah. Mm-hmm. 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 Yeah. Okay, this makes sense. So, sorry, I just didn't review that. So let's break this up into its components. So we have ax and ax times I plus, and I'm going to keep this in 2 dimensions for now for a second, plus ay times j, just to make it simple. So ax times I plus ay times j. That dot producted, so this is a, by the way, this over here is a. So that dot product with bx times I plus by times j. Okay? So now we just FOIL, and we'll get a scalar. So this is going to be a scalar, if you remember. So it's going to be ax dot bx. Wait, so it's going to be axi dot bxi, right? What would that be? Well, that is the magnitude of ax times the magnitude of axi times the magnitude of bxi, which is just going to be ax and bx, times cosine of theta. Cosine of theta in this case is going to be 0 because it's both I, they're both in the x direction. And so it's going to be ax times bx times 1, right? Because cosine of 0 is 1. So that's just going to be ax times bx. So we can write that. Ax times bx. Did that make sense? It's going to be, so what is the magnitude of axi? Well, the I is just for our direction, what our direction is. And so the ax would be the magnitude. So the magnitude of axi is just ax. That times the magnitude of bxi, which is just bx, times cosine of theta. Well, theta between I and I is 0. And so it just comes out to just be ax times bx. Now, the dot product, so now we would do axi times byj. What would axi dot byj be? Well, that would be the magnitude of axi, which is just ax, times the magnitude of byj, which would just be by, times cosine of theta. In this case, theta would be 90 degrees, in which case cosine of 90 degrees is 0. So that's just 0. So ax times bx plus 0, plus, and then we would do the ayj dot bxi, which is also going to be 0 for the same reason as the last one. And then we have ayj dot byj, which is just for the same reason as the ax bx, is just going to come out to be ay by. And so the dot product, and this is a new way of understanding the dot product, I believe, other than the tuple notation that we had before. No, this is the same way that we understood it before. But the point is, it's just going to be ax bx plus ay by. It's going to be the sum of all the components. And you see how this notation works out in the same way. So this, more than anything for me, shows that axi plus ayj equals a, because the dot product still works between them. So good, that was the dot product. Now, let's get into the real meat and potatoes. Now that we understand this notation, let's talk about why we created the notation, because so far we've done the same thing. Let's talk about doing the cross product. Okay, we're going to do the cross product. So, oh, this is going to be so painful. Imagine we have 2 vectors. Ax, sorry, not ax, that doesn't make sense. Just A cross B. What does A cross B mean? What do we mean when we say this? Well, let's break it up. And by the way, I'm going to get rid of my, the initial question is, suppose there's no kind of friction at all. Okay, no kind of friction means that there will be no force when something moves along a surface. Friction is what acts as a force. Suppose there is no kind of friction at all. Now, if an object has acceleration, that means the velocity keeps rising over time. Will the velocity exceed light speed? Ooh. Suppose there is no kind of friction at all. Now, if an object has acceleration, that means the object will keep rising over time. Will the velocity exceed light speed? Yes, in this simulation that you've created. Because what this means, okay, there is no such thing in physics as acceleration for free. That's like, there's no such thing in our universe as getting to accelerate for completely free. That's why things can't go faster than light speed. If you want to take something with mass and get it to light speed, you need infinite energy. Like, I've seen the equation, you straight up need infinite energy. The reason for that is that the energy it takes to accelerate an object needs to come from somewhere. In this simulation that you've created, it doesn't seem like it's coming from anywhere. There's no friction, and there's free acceleration. Like, you just have acceleration just for fun. So yes, the object will go faster than light speed in this simulation, but that can never happen in our universe because we don't have infinite energy. We can't just cause acceleration. But if you could just cause acceleration to an object for free, then you could get something to go faster than light speed. And yeah, you'd win a lot of money and probably a Nobel Prize if you could do that. Anyway, back to the stuff. Okay, what does the cross product mean? Well, let's break it up into its components. So AXI plus AY J plus AZ K. So all of that's our vector A, cross producted with BXI plus BY J plus AZ K. So these are all vectors, by the way. Every single thing that I have on the screen right now is a vector so far. BXI is a vector, everything's a vector. No, okay, ooh, yeah, there you go. That is the answer. Hope that makes sense. Give me more questions, it's fun, go for it. No, I don't want to rotate it 80 degrees, I want to rotate it 90 degrees. Rotate the page 90 degrees. Okay. What?
Just doing their homework for them.
No, I mean, I'm happy to do it, but it's not homework. It sounds like these are like fun questions you would find on the internet. Like, no one's gonna ask on a physics homework if an object has acceleration and no friction forever, will it go faster than light speed?
That's true.
Like, that's a weird question. It sounds like the kind of thing that like a conspiracy theory would say. Oh, and there's no friction in space, and so we can make something go faster than light speed. It's like, no, that's not how it works. But okay. But anyway, what does the cross product mean? Well, we're just going to take, we could FOIL it. We could take the cross product of every single thing. So what I'm going to look at right now, I just want to show you what I'm going to look at so that it's not confusing. We're going to take this entire thing and cross product it with this component. So we'll have AXI cross product with BXI. Okay, that plus AYJ cross BXI plus AZK cross BXI. So that's what we're going to have, essentially. And I'm going to write that all down. So we're going to have, oh boy, this is going to be ridiculous. We're going to have AXI plus BXI plus AYJ. Look at all the letters I'm saying. No, I'm sorry, not plus. I mean, there are pluses in a few places, but not in every place that I put them. It's AXI cross BXJ. Look at that, the crosses look the same exact as. Anyway, BXJ. No, I. That's an I, not a J. Jeez, this is ridiculous. Hold on. Let me get my eraser back. I want to make this look more like an I. Okay, so it's gonna be that. This is all one term. Plus AYJ cross, not plus, but cross BXI. So we're still sticking to BXI. So notice that BXI is the thing that we're doing, right? Like I said, we are crossing all of these with this, right? Okay, cool. So that, and then we're gonna have, so that's another term, okay, plus AZK cross BXI. Okay. Now what we're going to do is we're basically going to do like terms. We're going to do like terms. So for each of these things, we're going to find like the like terms. So the scalars would be AX. So okay, in this case, the scalars are AX and BX, and the vectors are I and I, right? So we're going to multiply ax with bx, and we're going to multiply, and we're going to basically cross product I and I. And we know what the cross product of I and I is because the magnitude is going to be 1, and we just have to figure out the angle. Okay, so let's do that. We're going to multiply like terms, and we're going to algebraically simplify this entire process. By the way, this is only like the first step. This is this with this. And then we also have to do this with, and then we also have to do this with all of this, and then we also have to do all of this with all of this, and that would be, and then we would add them all up as vectors, and we would do vector addition essentially. So anyway, let's do the first step, and then I'll show you a better way of doing this so that we don't have to do this every time, because it's really a waste of time. So what is AXI cross BXI? So that's going to be AX times BX. So that's like the first part. And that times I cross I. What is I cross I? We've done this. The cross product of two vectors is the magnitude of the vector of the first vector times the magnitude of the second vector times sine of theta. Right? So in this case, sine of theta theta is 0, which means sine of theta would be also 0. Sorry, it's confusing. But yeah, the sine of 0 is 0. So in this case, it's going to be ax times bx times 0, which is great. So that thing is basically forgetting. Like we don't have to think about that term right now, basically, essentially. Now the second term. So that's going to be by times bx. By the way, I hope it's clear that what we did over here is just the first step of FOIL. Like we took these and multiplied it with this, and then later we would take these and multiply with this. It's just like the first step of FOIL. We could have taken this and multiply it with these, and then this and multiply with these, but we didn't do it that way. So anyway, moving on. So by times, not by times by, but rather ay times by. Ay times bx, this doesn't make any sense. Bx and ay. Times the cross product between I and j. What is the cross product between I and j? Well, again, it's just going to be 1 times 1 for the magnitudes times sine of theta. Is going to be the magnitude, which in this case, theta is 90 degrees. So the sine of theta would be 1. Right? The theta between I and j is. So the magnitude of this is going to be 1. The magnitude of this vector is going to be 1. And the direction, well, let's think about it. So we'll put our hand on the I, we'll put our fingers up, and we'll see that it points towards us. Like I'm using my table, by the way, as my x-axis. So going right on the table, the edge of the table is the x-axis. We're going to go up, and for the j, or rather, hold on, I'm sorry. No, j is the first term in this situation. So I have to put my hand on the j and point it to the I, and we see that we're going away from us. So that's negative k. We're going away from us. Right? J, then I, so that's negative k.
Is your stuff in the washing machine?
Yeah.
It's done.
Yeah?
And Ari is moving to the dryer. If you want to turn that on, you should
Okay.
get
Alright, I'm going to take a quick break. I'll be right back, guys.
Sure, I'll move it.
Who's moving to the dryer?
Alright.
Yeah, alright. Great.
But each plug in quarters to pay for the dryer.
Yeah, is the dryer, do we have to pay for the dryer?
Yeah, $1.50 in quarters.
This whole paying for things is very annoying.
Yeah, I agree.
No, my keys. I don't want to be locked out. Where are my keys?
Where are your keys? That's your question.
They're on my bed. My question. Wow, you don't care about me at all.
I gotta figure out where I put my money.
That sounds like a you problem.
That is a problem.
Darling, I'm taking
Go ahead.
fabric
Yeah,
softener.
go ahead.
Is this fabric softener?
What? Yes.
Yeah? Okay. So I'm taking one. Please. Thank you. Alright, let's get back to this. Sorry about that, guys. Just had to do some laundry. It's laundry day. Ooh, more questions. Why does light not have infinite speed? I saw an answer saying without mass there is no restriction on their velocity, which means they can only travel at one speed. Can you explain? Why does light not have infinite speed? Well, first of all, it doesn't. I don't know why. I can't give you a why answer, but it doesn't. Infinite speed would mean that it would travel an infinite distance in a tiny amount of time, which light doesn't do. It takes time for light to travel, so that's just a thing. Okay, so I saw an answer saying without mass there is no restriction on their velocity, which means they can only travel at one speed. Without mass, there is no restriction on their velocity. Well, I don't know if something could have a velocity if it doesn't have mass, but this is getting into more complicated things. If it doesn't have mass, then I guess technically there would be no restriction on the velocity, because accelerating it even a little bit would make it go very fast. So, I don't know. Which means they can basically infinitely, like it would be a divide by zero. If you don't have any mass, then accelerating it would be a division by zero, which would break laws of math. So that would be problematic. Yeah, no, first of all, there cannot be an object with infinite mass. That like breaks the definition of object, really. So, but in terms of if it was like a wave, if there was like a wave but how would you accelerate a wave? Like what kind of force? This is getting into like Newtonian mechanics versus Einstein's way of understanding the universe. It's very complicated. This stuff is way above my head. Like I can't even do Newtonian mechanics properly. That's why I'm taking a mechanics course. And why is light speed c? Well, that's just the name we have for it. That's just what we call it. That's the number, 3 times 10 to the whatever. It could have been any large number or real number scale, or just a fundamental. It is a fundamental. Like basically, light speed is treated kind of like a fundamental constant of the universe. So yeah, it would be similar to say c with relation to g. But that's how I think of c. I think of c as a fundamental constant of the universe. Like that's just the speed of light. But anyway, the real answer to those two questions was I don't know. Okay, moving on. So ax times bx times 0 plus ay times by times, we established that this is negative k using the right hand rule. Plus az k hat cross bx I hat. So again, this is not going to be 0 because they're different like different base vectors. But we know that it's going to be az bx, and that we know, az bx in terms of magnitude, times what would the vector be? So let's figure it out. So we're going to put our right hand on the x-axis for the the right hand going toward us for the k, moving it to the I, so that's just j. It's going up, so that's just straight up j. Okay, and the point is this whole term cancels out, and the first vector that we have is this crazy person. And all we have from here is the k dimension and the j dimension, and yeah. And by the way, we could take the negative out and we could just say minus like ay bx times the vector k. And so you would do this process, like I said, for now we would do it for this term and all of these, and then we would do it for this term and all of these, and then we would do vector addition / subtraction, and then you would get your resultant vector. It's a pain in the neck to do, and that's why we know another way of doing it. So I'm going to show that new way right now. Let's rotate our page by 90 degrees. Okay, so now I'm going to show a new way of doing it. And the better way is using things called determinants. So let's set up our thing. A cross B equals something called a determinant. I don't know what these are. I'm going to do some research, but here's how you do it. A determinant looks something like this. It kind of looks like a matrix, but it's not. And it's like this. It's an operation, basically. It's kind of like multiplication, but it's an operation. So we have I hat. Let's put I hat up here. We'll have j hat. Let's put j hat up here. And we'll have k hat. This is how you set it up, k hat. And then you have ax, ay, and you have az. And then you have bx, and you have by, and you have bz. So that's how you set up your determinant. So this is the cross product. Now this simplifies when it's like three-dimensional like this, I'm gonna make a new page because I need room. Rotate this page 90 degrees. Great. So this whole thing that we have over here simplifies to I hat times another determinant, like a mini determinant, and it's going to be all the non-x's. So it's going to be ay and az, and it's going to be by and bz. And then this minus, it's very annoying. It's going to be that minus j. So the next part, the j part, is going to be similar, ax, ay, and bx. Sorry, az. J is for y, so it's all the non-y's. And bx, and then bz. Sorry. You know what? Let's just back up a little bit. bz. So that's the j part. Plus k hat with the times the k hat determinant, which is going to be, by the way, all this is multiplication, so it's I hat times the determinant. And a determinant, like I said, is an operation. Like you could view this as a number, but it's basically like multiplication, like the same way it's not basically like multiplication. It is an operation in the same way addition is an operation, multiplication is an operation, division is an operation. It's just a rule that relates all these numbers together and gives you a new number. Okay, so I don't know why there's a line here. But anyway, k hat times the new determinant, which is going to be ax, ay, bx, by. Great. So that is our determinant setup. Now we have to establish how to solve these determinants. So the rule of determinants is that you do this one times this one, this number times this one, plus or minus this one times this one. Right? And then that's for all of them. So it's going to be this one times this one minus this one times this one. That's what a determinant means. So let's make a new page. Let's rotate this page counterclockwise 90 degrees. And let's set this up. So it's going to be I hat times, because that's what we've been doing. And again, this is scalar multiplication essentially, because this is a vector, and then the determinant is going to be a scalar. So I hat times ay times bz. Ay times bz. Minus, and then I guess this is going to be az times by. Right? Right. Az times by. Great. And that minus j hat times its determinant. And again, the reason why it's minus j hat is because we have a minus over here. Why is there a minus over there? I don't know. But maybe after I explain this in terms of the rule, we can go through it together and get the intuition. Okay, but I get the best explanation. Okay, from you. Okay, first scenario is not possible because it causes division by 0 in equation, and answer to second question is light is just a fundamental constant. Basically, that's how I would answer it, but I could be wrong. I'm confident. Saying that the first scenario is not possible because it causes division in 0. Where would it cause a division in 0? Let's take a look. So we have this rule, this Newtonian rule, that F equals ma. We could rewrite this as a, the acceleration that an object experiences, is the same as the force that you apply to the object divided by its mass. So basically a force would be like me pushing it. What if I push it with a certain force and it doesn't have any mass? Well, that's going to be F divided by 0. Equals a. That, you can't do that. No division by zeros. It's not allowed. It's stupid. The reason why you can't divide by 0 is actually very fun, because the answer is that if you could divide by 0, then all the numbers in the universe equal all the other ones, and that's definitely not allowed. But it's also a weird sentence to say that since a rule of math doesn't allow you to divide by 0, it also means that you cannot have an object with 0 mass that is being accelerated, which is a weird concept. And yeah, and you can't say that the object with 0 mass has a velocity and not an acceleration, because acceleration is a derivative of velocity, and that would be 0. Like if it has constant velocity, then the acceleration would be 0, but that would imply that dividing by 0 equals 0, and we know that that's not true for reasons that I could demonstrate algebraically. But But anyway, yeah, that's the thing. That's the deal. That's the dealio. Moving on, or moving back really. So it's gonna be j times its thing, which is gonna be, come on, ax bz minus az. Okay, so ax bz minus b, or rather az bx, and then that plus k hat. The reason why it's plus k hat is because over here we have a plus k. Why do we have a plus k hat? I don't know, but that is the thing. And then that's going to be, so k is the z, right? So it's going to be ax by minus ay bx. Great. If you solve all of this, this gives you the cross product vector. So that is the cross product. So let's back up. Hold on. This all equals A cross B. Right. Let's should we do this? I want to do this. I want to see if we could develop the intuition. So remember that I do know dividing by 0 is not possible. I saw a lot of videos why it's not possible. One from TED Talk is very good. Anyways, thanks. You're welcome, 100%. It's cool that you're playing around with these ideas. They're really fun, I agree. So yeah, let me know any other questions you have at any point or whatever. I'm happy to discuss them. But okay, but we established that the cross product is basically this kind of operation where you do all of these times all of these. I don't know why doing that would lead to like this. Oh shoot, no, come back. Oh no. There you go. Great. So I don't know why doing that would lead you to this, what's it called, determinant notation thing. Maybe I'll watch a video on that. I'm sure someone has a video on that. You, whoever's watching this, if you're watching this for review, go watch a video on that. I'm not explaining that. It's too complicated. I don't know it. But moving on. So let's do a practice problem. Why not? By the way, you want to do math after I'm done with this video?
Yeah.
Okay.
Bring them easy ones out of the way.
Right, I should be done within like the next half hour at least, at most.
Just ask me to foil. Like, I'm not wasting my time on that.
Yeah, you're not wasting your time doing foilings? Dude, if you could see the things I'm trying to do here. Foiling is relaxing compared to this stuff.
But like,
freaking cross products, so annoying.
You need help with stuff that I didn't take notes on, which is the first section.
Alright, so let's do a practice problem. Let's say we have vector A equals 1, 3, negative 1. I don't know why I erased everything. I'm going to need that, but whatever. And let's say we have vector B equals 4, 1, 3. Right? This is not vector notation, clearly. This is a tuple notation. What is A cross B? That's a good question. So, we already established like the whole determinant thing, so we could skip a little bit, and let's just set up our determinant. So we're going to have I hat times its determinant. What will its determinant be? It's going to be all the non-x's. So it's going to be 3 and negative 1 for the A, and then for the B it's going to be 1 and 3, right? Because it's going to be this and that, and then this and that, right? So it's going to be I hat minus j hat times its determinant. What will j hat's determinant be? It's going to be 1, negative 1, and then, I'm sorry, no commas. There are no commas in the determinant. That's not how it works. 1 and negative 1. Sorry. 1 and negative 1. And we'll have 4 and 3. Right? And then we'll have k hat, so plus k, well, you know, I'm going to do this on a new line. Plus k hat, and its determinant, which is going to be 1 and 3, and 4 and 1. Great, now let's set it up more, let's solve the determinants essentially. So we're going to have I hat times its determinant, which will be 3 times 3 minus negative 1 times 1, which is going to be plus 1. So 3 times 3 is 9, 9 plus 1. There you go, that's I hat's determinant. Minus j hat times its determinant. So that's going to be negative 1, okay, 1 times 3, it's 3 minus negative 1 times 4, which is going to be plus 4. So 3 plus 4. 3 plus 4. And that plus k hat times its situation, which is going to be 1 times 1 is 1, minus 3 times 4 is 12, so 1 minus 12. Yeah, 1 minus 12. 1 minus 12. Okay, now let's set this up in our vector in our vector notation, the way we know it and love it. So we're going to have 10 I hat minus 12 j hat minus 12 j hat plus, or no, minus 11 k hat. And this, that equals, and then this equals in our tuple form 10 comma negative 12 comma negative 11. That is our vector. That is our resultant vector from these two vectors, cross-producted. Let's do some tests to make sure this is correct. So first of all, we know that the magnitude of C, let's just call it C, which is our resultant vector. I'm gonna call this C. So C equals that. We know that the magnitude of C equals the magnitude of A times the magnitude of B times, I don't know how I'm going to calculate sine of, what would sine of theta be in this case? That's weird. Can you draw me a right-angled triangle? Hold on. I'm not actually going to do some checking. We're just going to Google it to see if the answer is correct, because I don't know how I would check this. No, I also got rid of the C. Can you draw me a right-angled triangle where any angle is sine 90 degrees? What? The sine of 90 degrees is 1. I cannot draw you a triangle where every angle is 1, because the sum of all the angles needs to be 180 degrees. And I definitely can't draw you a right-angled triangle where everything is 1, because the sine of 90 degrees is still 1. Why sine 90 degrees is necessary or useful in these scenarios, or is it not? It's not. It's not. That's the answer. The answer is it's not. So, yeah, let's think about it this way. A right-angled triangle would look something like this. Here, this is one side. This is another side. Sorry, hold on. Okay, and then this is the final side. No, I actually want that to be a different color. Great. Cool. So this would be a thing, and the right angle exists over here. That means that this angle is 90 degrees. Okay. You want me to do a triangle where every angle is the sine of 90 degrees. So the sine of 90 degrees equals 1. You know that from the unit circle. So clearly I cannot do that, because this one needs to be 90 degrees for it to be a right triangle, and you want all the angles to equal 1. So already we have a problem. More than that, let's call this angle A, let's call this angle B, let's call this angle C. A plus B plus C equals 180. If A is 1, and B is 1, and C is 1, then they equal 3. 180 is not 3. So clearly we've done some problems. So I'm probably misunderstanding your question, but anyway, yeah, no, I can't. All right, now we're going to Google. We're going to Google to see if the answer is correct. So what is the cross product between 1, 3, negative 1? I'm going to Google this over here, and you won't see it, but I'm going to see it. Cross product calculator. So I want 1, 3, and negative 1, and I want 4, 1, and 3. 4, 1, and 3. Yeah, 1, 3, negative 1, 4, 1, and 3. Go. I get it right? I hope I get it. 10, negative 7, negative 11. 10, negative 12, negative 1. Okay, I did not get it right. I got the first one right, but more than that, I did not get it right. So what did I get wrong? It's minus j times 3. It's minus j times 3 plus 4. It's 3 plus 4. Why did I do times 4? That makes no sense. 3 plus 4. Sorry. That makes no sense. I don't know why I did this. So minus 7. And this is going to be 1 minus... Yeah, I did it... Yeah, this is weird. I don't know what I was thinking over here. Negative 11. And then this one over here is going to be minus 7. Yeah, okay, fine. Okay, no, I think... Okay, I count that as I did it right. I just did some stupid mistakes. Bro, one watching literally. I guess that's you at this point. Shuba Goel. I'm not really doing this for people to watch. I'm doing this more just for me to practice and also for me to look back on to study and also for me to look back on when I'm like 50 and look back on and be like, oh my god, what a cute kid. It's gonna be fun. I'm looking forward to those days. So, anyway, moving on. There you go. That is the cross product shown using vector notation. What?
Oh, it's in chat.
Oh, yeah. Shuba Goel. I'm sorry if I'm mispronouncing your name. Shuba. Shuba. The problem is there's only one vowel in your name, and I feel like it necessitates another vowel. You're missing a vowel. Okay. I think there's only a little bit more that we have to do. So let's just do it. Okay, let's talk about an example. Let's bring these vectors into actual physics now. And let's stop talking about them as if they're abstract ideas, which we've been talking about them such as they were until now. We've just been discussing them as a mathematical idea. Let's talk about them as a physical idea. So we could describe many things using vectors in physics. Let's make a x and y axis and z. We're gonna have to get used to having a z there as well. Okay, new question. I didn't say that every angle needs to be 90 degrees. One angle needs to be 90 degrees since it's a right angle. But can any other angle be sine of 90 degrees? Can any other angle be sine of 90 degrees? Which left angle to be 0? Okay, no. If another angle is the sine of 90 degrees, then the other... Okay, hold on. Oh boy. You, my friend, are making no sense. So which grade maths are you doing? I have learned this in 9th grade. I'm doing this in physics in college. You learned cross product in 9th grade? Jeez. No, I'm doing this in physics in college. It makes sense that the first few classes are the same, since he's just sort of getting people on the thing. But I'm about to actually show calculus, which I doubt you learned in 9th grade. But anyway, yeah. Okay, let's talk about this. Happy, good. You want a right triangle, right? So let's make our right triangle. Okay, one of them has to be 90 degrees, right? One of the angles. So we're going to make that this one. This one is 90 degrees. Now you want one of the other ones to be sine of 90 degrees. I think he's talking to you. I doubt you learned trig in 9th grade either, but whatever. I think 9th grade is usually for algebra 1, no? Algebra 2?
Maybe algebra 2.
Yeah.
You could have done, because my school had they had geometry and trig in 9th grade too.
Maybe if you're on honors, I guess.
That was an honors track, yeah.
Yeah, smarty pants. Okay. So you want one of the angles to be 90 degrees. The other angle you want it to be sine of 90 degrees. So sine of 90 degrees is 1, so that's just 1 degree. Which means that the last angle would be, the sum of them would need to be 90, so the last one would be 89 degrees. So yeah, this would be the setup for your triangle situation. 90 degrees for the right angle, 81 degrees for the other one, and then 1 degree for the top one, because you want sine of 90 degrees. Let's just show this. Sine of 90. There you go. Great, moving on. So we have our x, y, and z axis. This is a terrible x, y, and z axis, but whatever, it's going to work. Okay, let's talk about something that we could describe in physics using vectors. So let's make one vector. And let's talk about like this as if it's position. So here we have one position. And we could call this like R1, R sub 1, and that's a vector. And here, okay, so that's our position. You have a position. There you go. That is a thing in physics described using a vector. You could describe position. You could also describe displacement. So imagine R1 moves to the point R2. R2. So this is its new position. Okay? The displacement would be this thing. And we'll call this vector D. How would you calculate vector D? What is vector D? Well, in this case, it would be R2, vector R, I don't know why it's squared. Here, R sub 2, just pretend that stuff's, okay. Bro, ask any Indian, then you will get to know how much maths we get taught. Oh, that's funny. Okay, so I guess you're Indian. No, that's basically what he's saying. It's good that they teach a lot of math in India, I guess, math is a very good subject. It's very powerful. Okay, right angled 90 degrees plus sine of 90 degrees plus 0 90 degrees equals 180. Not possible, right? I mean, how do you prove that sine of 90 degrees equals 1 just by drawing? Okay, let me show you how sine of 90 degrees is 1. Let me show you how the sine of 90 degrees is 1. So, trigonometry functions are all based on the circle. They all follow along the circle. So imagine we have like an x and y axis. And then imagine I draw a circle for you. I need to hold it for it to turn into a circle, I think. No. I think I need to click shapes. I want to make a shape. I want to make a circle. No, that's an ellipse. I want a circle. It's still drawing ellipses. Stop with the ellipses. Oh, I get a nice circle. Oh, I could mess with it. Okay. No, I can only like rotate it. It's keeping the same dimensions. Maybe if I just draw quickly. No, it's also not a circle. So you know what? Just pretend this is a circle. So here we have a circle. And imagine we have a triangle that lives inside this circle. Okay. The sine of, okay, and we have this angle over here. Let's call that theta. Sorry. I'm still on the shape tool. So we have a theta. So the sine of theta is going to be the y situation. Oh, and by the way, this is a unit circle, which means its radius is 1. The radius is 1. So this is going to be a 1. This is going to be a 1. This is going to be a 1. And this is going to be a 1. Okay? So the sine of theta is the y component, sorry. Is the y, that's not a 1, that's a 7 or something. Here, 1. The sine of theta is the y component of our triangle. The cosine of theta is the x component of our triangle. This is the definition of sine and cosine, by the way, so don't ask me why. Like, this is what it means to be sine. That's what the function sine means. So there you go. Now, 90 degrees is over here. Okay? This is 90 degrees, right? If our angle, theta, comes all the way to 90 degrees, then the y component of this is 1, and the x component is 0. So the sine of 90 degrees is 1. Furthermore, the cosine of 180 is 1, and the sine of 180 would be 0, right? Because we spin all the way around. Or rather, the cosine is negative 1, I'm sorry. Cosine is negative 1. And also the sine of 270? 270. The sine of 270 is 1, and the cosine of 270 is 0. Or no, the sine of 270 is negative 1, I'm sorry. But anyway, there you go. That is like trigonometry, very basic. Watch some Khan Academy videos, it's very interesting. But that is the unit circle. Like, that is what sine, cosine, and all that jazz means. And tangent means something else. Tangent is very fun. Tangent's like the slope. But anyway. Okay, so displacement. Displacement is R2 minus R sub 1. Okay? Right? You could see this by doing the tail to tail, right? We have it tail to tail over here, and then we draw it between the two. And obviously, we've moved from R1 to R2. That's how you know the direction. So, and displacement itself is a vector. But it's a vector. Yeah, displacement itself is a vector, and you could draw the vector from the origin as well. Same vector as we've established. It doesn't matter where a vector is coming from. It just matters its magnitude and its direction. So there you go. That is an example of using vectors in real life. In physics, like a physical manifestation of a vector. So where you are, dear viewer, in relation to me is a vector. Unless I'm watching this, in which case time has stopped and whatever. Time has moved on, I mean. Time does not stop. As far as we know. Unless you're going like light speed. But anyway. Shifting origins. I don't know why he talked about shifting origins in class, but I'm not going to talk about them right now. Doesn't seem like it's important, but it may be. Velocity. Let's talk about velocity. Because he talked about it last lecture because he just had the time. And so he added this into the last lecture, even though it has nothing to do with what we were discussing. But anyway, velocity. Velocity could be described as, yeah. So imagine you have R1 at time 1. R1 at time 1, and that becomes R2 at time 2. Okay? So we're moving from R1 to R2, and it takes time 2 minus time 1 amount of time. Okay. The average velocity, AVG, vel, equals, and this you should know from basic physics, the average velocity equals r2 minus r1, your displacement, divided by the amount of time it took, r2 minus t2 minus t1. That is your average velocity. Now the problem is, you may think that this means that is your velocity. Now we got 3 viewers. Congrats. Thanks, man. By the way, how did you guys find this video? This is like a weird video. What are you guys doing on YouTube watching this? You guys are weird. But anyway, r2 minus r1 divided by t2 minus t1. That is your average velocity over the interval t1 to t2. But that is not necessarily the exact velocity at every moment from t1 to t2. Imagine displacement. What if your displacement looks something like this? We're going to have it at x and y grid. And we're going to talk about only one-dimensional displacement for now. What if here, this is time, and this is position. So what if at time t equals 0, your position is 0, and this is your position over time, right? This means that, imagine we choose time 1 to be this. I hate how I can't just make a dot. Time 1 is this, and time 2 is this. Hold on. Time 2 is this. Your average velocity looks like, well, like that, kind of like that. No, sorry. Your average velocity is the slope of this line that I've drawn. Hold on. Let's show this more clear. So you see that this line could be modeled as your position changing, and the average velocity is the average rate at which your position changed from the first point to the second point, right? But notice how your actual average velocity is the slope of the parabola, but the slope of the parabola is changing. It was on my recommended page. Why was it on your recommended page? Anyway, welcome. I'm reviewing my physics lectures. Okay, so your actual velocity is the slope of your position graph. Okay, now I'm going to ask you a childish question because I see many people having problems with orders in math. What do you follow? I do PEMDAS. I don't even know what BODMAS means, but I just think of it as PEMDAS. Okay, great. So yeah, your average velocity is the slope of this line. Your actual velocity is the slope of the parabola at every moment. Your velocity at every moment is the slope of your position graph at every moment. Now this is getting into complicated ideas, but since this is supposed to be a calculus physics, I'm going to assume that you've encountered this idea before, dear viewer. This is what a limit means. So imagine I wanted to find like instantaneous velocity. Okay? What is the velocity at time t equals 1? Like over here, this one thing that I have. Right? I can make this like 2. Okay? What is my velocity at times t equals 2? Well, we could calculate like I was watching master physics videos, that's why. I guess. Okay, well, welcome. Imagine we brought these points closer and closer together. Or imagine we brought the point at 2 closer and closer together. You would get a better slope. You would get closer and closer to the tangent line at position 1. And that tangent line is your velocity at times t equals 1. So the instantaneous velocity is actually a limit. It's a calculus limit. So let's discuss that. If you don't know what limits are, I encourage you to watch the 3 blue 1 brown video about limits. It's a great video. 3 blue 1 brown, great video. Watch it. Watch their entire course on calculus. Really. Okay, so your instantaneous velocity. Imagine we have a function. We have like p of t. P of t equals position. Position at t. Like that's your position at time t. We get to learn that we should do dividing first, but some people argue that we should do multiplication first if we see it first from left to right or whatever. So I actually had a very good question about this. Let's work at a problem. 3 times 5 divided by 7. 3 times 5 divided by 7. In theory, according to the rules of PEMDAS and mass and whatever PEMDAS, you could do this at any order you want. So let's just try it out. You know what? No, I don't want this. I want like divided by, let's say 10. Or yeah, let's say 10. Divided by 10. So 3 times 5 is 15. 15 over 10 is 1.5. Right? Okay, let's try something else. 5 divided by 10 is 0.5. 0.5 times 3 is 1.5. So, yeah, so far it works. What about 3 divided by 10? 3 divided by 10 is 0.3. 0.3 times 5 is 1.5. Yep, so far everything works. So yeah, you can do it literally whatever order you want. LOL, his name is Big Chungus. Yeah, okay, I guess that's funny. You guys enjoy that joke? Okay, so anyway, imagine, let's get back to physics. P of t equals position at t, at time t. Okay, that's how we're defining it. The instantaneous velocity, so vel of t, equals the following. The limit as delta t approaches 0 of p of t plus delta t minus p of t over delta t. You should notice this form as rise over run. That's basically what we're doing over here. This being the rise and this being the run. We're looking for a slope, but we're looking for an instantaneous slope on a changing parabola type situation. So yeah, that is a function for velocity. You could get your instantaneous velocity that way, which is pretty cool. At every point, even on a changing thing. It's really cool, actually. Let's see what I wrote over here. What did I write over here? When do we use which? So let's show something. Let's discuss when you would use which. So let's say we have a function. X of t, so your position at time t, equals, and I'm actually going to make the equation, equals at plus b. Now you should notice that this is a line. Sorry, the plus really looks like a t. It's really annoying. Plus b. Now this is a line. This is going to be a line. Slope is a, y-intercept is b. So what would be the average velocity? Well, the way you would calculate average velocity is you would do x of t sub 2 minus x of t sub 1 over t sub 2 minus t sub 1. What will this equal? What do we get from this? Well, let's solve it. We get a times t sub 2 plus b minus a times t sub 1 plus b, all of that over t sub 2 minus t sub 1. Now the truth is we don't need the parentheses, so we can really just do whatever we want. So the b's will cancel. I'm sorry, no. Yeah, so we'll distribute the negative over here. So minus a times t1 minus b. Now this should tell you something interesting. That velocity doesn't care about your starting position. Your starting position would be shown with b, like the y-intercept. So I'm not going to read the explanation of the joke. I don't care enough. Sorry. So your velocity doesn't care about your starting position, which means that the b's will cancel. And notice that the b's do in fact cancel. And then we have, we could get the a out, because the a is a common thing. So we'll have a times t sub 2 minus t sub 1 over t sub 2 minus t sub 1. And these will cancel, and we'll be left with a. So the velocity is a, or the average velocity between two times is a. Now let's see what the instantaneous velocity is. Okay. What is the instantaneous velocity at a certain point? Well, let's calculate it. So it's going to be the limit as delta t approaches 0 of it's going to be of a times t plus delta t plus b minus a t minus b, because it's going to be like minus the whole function again. Minus, did I write it? I didn't write it anywhere. I guess I deleted it. But it's going to be minus the function, so that's going to be a t plus b, but it's going to be minus that, so it's going to be minus a t minus b over delta t. Now the problem is we can't just plug in 0 yet, because then we'll get a division by 0, but we can figure things out. So first of all, notice that the b's will cancel again. B's cancel. Wonderful. we could take an a, so we'll be left with the limit as delta t approaches 0 of a times t plus delta t minus a times t over delta t. So we could distribute the a, and we'll be left with, and just imagine I'm putting the limit down here again, a t plus delta t minus a t. Sorry, I don't know. I'm doing a lot of. So at plus a delta t minus at over delta t. And you can see that these two will cancel, the ATs will cancel, and we'll be left with A delta, so delta T times A over delta T. The delta T's cancel, and we're left with just straight up A. Okay, does 10 divided by 2 times 5, do 10 divided by 2 times 5 and show it's the same no matter what order we follow? Okay, let's try. Sorry, no copying pages. Rotate this page clockwise. Okay. 10 divided by 2 times 5. Let's do like the first one that I want to do, which is just 10 divided by 2 times 5, which is just going to be 10 divided by 10, which is going to be 1. So 10 divided by 10, it's going to be 1. Great. So that's the first way of doing it. Now 10 divided by 2. Uh-oh. 10 divided by 2 times 5 is going to be 10 divided by 2 is 5. Uh-oh, we have a problem here. Yeah, 5 times 5 is 25. Okay, that is problematic. Yeah, and then we'll have the other option, which is going to be 10 times 5, which is going to be 50, divided by 2 is 25 again. So 2 of the ways of solving it lead you to 25. 1 of the ways of solving it leads you to 1. That's very interesting. 2 times 5 is 10. That much we know. 10 divided by... Yeah, this is problematic. I remember I discussed this once. Let's look at Desmos for a second. I'm typing in on Desmos on my computer. Let's find out what Desmos says that it is. So 10 divided by, oh right, Desmos doesn't have divided by. 10 divided by 2. So Desmos is going to say that it's is that it's 1, by the way. 10 divided by 2 times 5. Desmos says that it's 1 because division itself is a weird concept. Division is not necessarily a complete inverse of multiplication. I mean, I guess it is. But it really depends on how you phrase the question. If you put parentheses by the 2 times 5, it's going to be different than if you put parentheses by the 10 divided by 2. Because that's how things like this work. Yeah. Yeah, I would say that it's 1. Looking at this like myself, I would say that it's 1. Because I would just do division. Division, even the symbol of division makes it look like it's 10 over 2 times 5. But yeah, it could also, but you can also say it's just 10 over 2 times 5. Right? It's going to be 5 times 5. Yeah. Yeah, 10 over 2 times 5. What's interesting is that there are 2 ways of doing it, and only one of them leads you to 1. Like 10 times 5 is going to be 50, and 50 divided by 2 is 25. Yep, you're showing an interesting quirk. Maybe if I type it in on words in Google, I wonder what they would say. Let's see. 10 divided by 2 times 5. So Google says it's 25. Yeah, Google says it's 25. If you type it in on a computer program, it would say that it's 25, by the way. Like if we go to a Python interpreter, you can't see this Python online. if we go to a Python compiler online, just because I don't want to open it up in my computer, and we do 10 divided by 2 times 5, I'm pretty confident that this will evaluate to 25. So yeah, that's 25. Okay, so yeah, the answer is that it's 25. Use Queso Calculate or Samsung Calculator on your phone. I don't think I have a calculator on my iPad, but the phone would probably say. What would the phone say? Huh?
What's the equation?
10 divided by 2 times 5. No, it depends what you put it in as. Like 10 divided by 2 is 5. 5 times 5 is 25.
This is 25.
Yeah, but what about 10? What if you say 10 divided by 2 times 5?
1.
Yeah, so that's weird.
Yeah, it's real weird.
Yeah, yeah. But yeah, computers will equate that to 25. And honestly, it doesn't matter. It's just about what convention means. Like, you could describe anything. It's just a language. Like, math is just another form of language. So just choose one and be consistent. And all of humanity needs to choose one and be consistent. But anyway, what were we talking about? Right, limits. Okay, so the point is we get A and A both when we're doing it the average velocity and when we're doing it as a limit. So which one do you use when? And the truth is, when it's a line, the reason why they were the same is because the equation for position was a line. And so the average velocity was the same thing as the instantaneous velocity. But if it was not a line, say if it looks something like this, imagine if x of t equaled negative, how did he do this? Negative dt squared plus c. What if it looked like that? What if this would be a parabola, by the way? So how would you solve this? Well, the average velocity, you can't do it with the average velocity because it will depend on time. Let's solve the average velocity. So the average velocity would be negative d times t sub 2 minus t sub 1 squared plus c. All of that minus, and now we have to do like a bunch of minuses. So minus negative d, so it's going to be plus d. Oh, sorry, no, I did this all wrong. This is not how you solve average. So sorry, negative d times t sub 2 plus c plus d times t sub 1, because it's going to be like minus the whole function, so we have to distribute the minus c. So, and then all of that divided by t sub 2 minus t sub 1. So first, the c's cancel, right? Constants don't matter, right? Great. Then we have, wait, hold on. This is weird. Oh, it's squared, by the way. Sorry, t sub 2 squared and t sub 1 squared. Not bad. And we also have wait, hold on. This is weird. How about we just get a negative out? Let's just do like, so if we, let's go back one page and let's erase all of this. So again, what we have, I mean, I guess we could solve this in a second. We have negative d times t sub 2 plus d times t sub 1, and all of that over squared, all that over t sub 2 minus t sub 1. So we can get a negative 1 out, so negative 1 times negative 1 d t sub 2 squared plus d t sub 1 squared over t sub 2 minus t sub 1. So we can further, let's go back again, but we're actually going forward. We can further simplify that to be d times negative t sub 2 plus t sub 1. This is very weird. I feel like I'm doing this wrong. Squared over t sub 2 minus t sub 1. I'm definitely doing this wrong. don't understand how this guy calculated this. I see it in my book. It's so wrong. It's so not true. Right, yeah, these need to be flipped. This is very strange. Hold on. Did I write this down wrong? Negative d times t sub 2 squared plus c, right? That's x of t sub 2 minus x of d sub 1. So minus, yeah, I think this is all right. It should be 25 according to me personally. Asian people mostly use BODMAS, where division is first, which always leads to a single answer. All calculators do division first, but PEMDAS leads to PRB. Leads to this problem. Yeah, you're right. PEMDAS is problematic. Okay, cool. I guess it is problematic. Fun. Something is very wrong here. Something is very wrong with my calculations here. Let's do this all over again. So we have our function x of t equals negative d t squared plus c. Okay? Now the average velocity is going to be d times t sub 2 squared, negative d times t sub 2 squared, plus c, okay, all that, minus negative d times t sub 1 squared, plus c. Okay, great. This is going to be negative d t sub 2 squared plus c, plus d sub 1 squared, plus d sub 1 squared. No, sorry, not d sub 1, plus dt sub 1 squared minus c. C's cancel. We're left with, what if I make this one no, this is weird. What if I bring out a d from both of these? So I'm left with like d times negative t sub 2 squared. But it's not negative t sub 2 squared, because negative t sub 2 squared is just t sub 2 squared. Something is so wrong with this. It's the negatives that are freaking me out. Plus t sub 1 squared. And by the way, like this all needs to be over t sub 2 minus t sub 1. We know that. So this is a difference of squares, I guess, in theory. So we have d times t sub 2. Yeah, it's t, so yeah, come on. T sub 1 plus t sub 2, and then we have times t sub 1 minus t sub 2. But neither of those are t sub 2 minus t sub 1. So that's weird, because that's what we're looking for, to cancel them out. But yeah, have a great day too. Maybe we'll meet again. Yeah, for sure. Have a great day. Bye. This is so weird. It's funny because in my notes it doesn't make any sense. What if we take out a negative d? Yeah, if we take out a negative d, that makes sense. That makes sense, I guess. So fine. So let's go like this. Over t sub 2 minus t sub 1. We know that. Okay. So just keep in mind the t sub 2 minus t sub 1. Let's figure out the numerator first. So if we take out, so first of all, yeah, the c's are going to cancel. and this is going to become a plus. And so if we take out a negative d times t sub 2 squared minus t sub 1 squared, I guess we can do that. Yeah, I suppose that works. And then we can say that this is a difference of squares, so this minus t sub 1. So this is a difference of squares, and then we could say that it's going to be negative d times t sub 2 plus t sub 1 times t sub 2 minus t sub 1, all of that over t sub 2 minus t sub 1. Those will cancel, and we're left with negative d times t sub 2 plus t sub 1. Now this equals your velocity. When you calculate it by average velocity, this is going to be your velocity. The problem is, now your velocity clearly depends on your 2 points of chosen time. So it depends on time. So this is not like your instantaneous velocity at a given point, because you first of all need 2 points, and it depends what those 2 points are. So this is where the idea of a limit comes in. So let's do this all again, but limit-wise. Let's use the limit instead. So again, let's imagine our function, that displacement d of x, or rather no, x of t, that's how we said that, x of t equals negative d of t squared plus c. So that's this as a limit. So the limit as delta t approaches 0 of, let's do this, okay, negative d times t, t plus delta t squared plus c, minus negative d times t squared plus c, all of that over delta t. So that is our limit. Now let's solve this. So first of all, just imagine I'm putting the limit down, like I'm bringing the limit down. Let's first of all realize that this thing's going to come in here, making this a plus, making this a minus, so the c's are going to cancel, right? The constants don't matter. That's something that we've established. Then we're going to have something that looks like this. We're going to have negative d times, and now let's FOIL all this. So negative d t squared plus 2t, so plus 2 negative d, so actually let's just make it minus 2d t delta t. There you go, that's the second term. Then we have delta t squared, so plus delta t squared times negative d, so it's also going to be a minus. Sorry, this is not t delta t minus d delta t squared. So that's our first term. All of that plus dt squared over delta t. So notice we have a plus dt squared and we have a minus dt squared. These two are going to cancel. We have, great. Yeah, great. So that's okay. So now let's bring the limit down again. We have, and we could take out a d. We could take out a d. We could take out a t delta t. Really is what I want to take out from all this. Right. This has a delta t in it. This has a delta t in it. So we could take out a delta t, and we could say delta t times negative 2d t minus d delta t, right, over delta t as the limit as delta t approaches 0. So now we could cancel this with that, right? And we could say that it is, we could say finally that our velocity is going to be the limit as delta t approaches 0 of negative 2d t, there's no delta t there, minus d delta t. Great. Now if delta t is getting to 0, let's just pretend that delta t is 0. So when delta t is 0, this whole term is going to cancel, and we're going to be left with the velocity at time t equals negative 2 d t. And if you know your power rule, this makes sense. So we're left with this as our final answer. And it's not Velt, it's Vel. And I don't know why I put a T there. It's probably because I've been typing T a lot, or writing T a lot. Great. So that is your velocity at time t, using the limit. In physics, this is denoted as dx, where x is a vector, over dt. So that's like the derivative of your position over dt. And then we have, okay, so this equals velocity, which is also going to be a vector, by the way. And your acceleration, which is also going to be a vector, equals the derivative of v over dt. And so you see how the derivative of, we've just shown how this is a derivative, by the way. If you know your calculus, it's a derivative. And so the derivative of position is velocity, and the derivative of velocity is acceleration. And if you know what the terms acceleration and velocity mean, that makes sense. One thing I want to do before we end the video is this. At our last lecture, my professor gave us a problem, and he said that we should do it. And so now I'm going to do it. So the problem is this. Find unit vector b, find unit vector b. Is this going to have a hat? Are all unit vectors with hats? I think all unit vectors have hats. Do all unit vectors have hats? Let me check. I'm sure I have it in my notes. Or is it just like the base vectors have hats? Vectors, they have that. Unit vectors, so yeah, so all unit vectors have hats. So find unit vector b with a hat, such that it is perpendicular. Find unit vector b, which is perp to 3, 5, 1, to vector a, which equals okay, so hey, I just came back thinking one thing. PEMDAS isn't wrong either. It hit me. D and M refers to division multiplication, right? So in PEMDAS, PEDMAS instead of PEMDAS. D is first, so division is first. Maybe a logical conclusion. Yeah, I guess so. I mean, again, it's just about convention, and I think they're still teaching PEMDAS in school, so they should stop that, and we should just, it's just a convention. Like, we all just need to agree on something. But yeah, I guess PEDMAS would make sense. Yeah, okay, anyway. So find unit vector b hat, which is perpendicular to vector a, such that vector a has components 3, 5, 1. Great, so there you go. So we're going to find it, okay. So let's establish this. So I'm going to put away my notebook and we're going to solve this. So it needs to be a unit vector b, which is perpendicular to vector a. So we could describe b as being a vector with b sub x, comma b sub y, comma b sub z. Now, by the way, this is not how he did it. He said that vector b needs to be on the right. So in theory, I guess there are two of them. There are two of them. There's one on the x-axis. There would be one on, if it's in the 3D world, there would be one on each given axis, or there would be two. There would be two potential answers for this, because there are two potential perpendicular things with unit length 1. I guess maybe there's even more. But he said that it needs to be on the x and y axis. He says that it should only have an x and y component. So we're going to get rid of one of these things. So it's just going to be bx comma by, okay, which is perpendicular to vector a. So what does it mean when you say it's perpendicular to vector a? Well, when we say it's perpendicular to vector a, it means that the angle is 90 degrees. So we have a thing for that. We could say that the dot product, so vector a dot vector b, equals the magnitude of vector a times the magnitude of vector b times the cosine of 90 degrees, which means it's 0, which equals 0. So the dot product equals 0. Okay? That's interesting, I think. And also, we know that it's a unit vector. So that means that bx squared plus by squared, the square root of both of them, equals 1. Which means that bx squared plus by squared equals equals 1, because we're just going to square both sides. Okay. Furthermore, we know how to solve the dot product, right? We know how to solve for the dot product. So let's show this. We could show that bx vector bx times ax plus by times ay. Bz we could just say is 0, right? So we could say so plus 0 essentially, because bz would be 0, equals 0. That's like the dot product. So now we have this, and we have this. We have two unknowns over here. We have by, we have bx and by, and we have two unknowns over here. We know ax and we know ay. So since we know ax and we know ay, we could create a system of equations. So let's first of all create our system. So we have bx times ax. What is ax? Ax is 3. Plus by times ay, which is 5. So plus by times 5 equals 0. And the other system we have is bx squared plus by squared equals 1. Great. So now that we have this system, we can solve for bx and by, because we only have two unknowns and we have two equations. So let's solve. So bx equals negative by times 5 over 3. That's what bx equals. So bx equals negative by times 5. So let's say negative 5 by, right, because we're going to move that over, divided by 3. Okay, so negative 5 by over 3 squared plus by squared equals 1. Okay, wonderful. Now let's simplify this whole thing. So negative 5 squared is 25. By squared is by squared. 3 squared is 9. So there you go. Plus by squared equals 1. Okay, now we can times 9 on both sides. So let's do that. So we'll have 25 by squared. 25 by squared plus 9 by squared equals 9. Okay? We could take out a by squared on both sides here, right? They have a common term. So by squared times 25 plus 9 equals 9. Great. By squared times 25 plus 9 is 24. 24. Sorry, no, that's not true. 25 plus 9 is 34. By squared times 34 equals 9. Right? I believe that's true. Okay, and then we have by squared equals 9 divided by 34. 9 divided by 34 is just equal to 1 over 4. No. 9 and 34 are not at all similar in that way. I thought it was 32. So this is just the square root. So it's going to lead to by equals 3 divided by, does 34 have a square root? That is easy. 34 would be 2 and 12, which would be, no, not 2 and 12. 2 and 17. So not 2 and 17. No, it does not have a square root. So it's going to be 3 over the square root of 34, which is going to mean that by equals 3 radical 34 over 34. I think. I believe that I did all that right. Let's make sure. So by no, I said bx equals by times 5 divided by 3. Equals by times 5 divided by 3, which meant that I guess I erased all the stuff, so I'm not sure if I did it right, but yeah. Here, let's so we know that we think by equals 3 radical 34 over 34. Let's type this into Google and just see if we're already wrong. So I'm gonna make a system of equations where okay, system of equations calculator. Okay, equation 1, a, so here, equation 1 is going to be, what is the equation 1? The equation 1 is, let's say a, which is going to be bx, so 3a plus 5b equals 0. That's the first equation. The equation 2 is going to be a to the power of 2, a to the power of 2 plus b to the power of 2 equals 1. And I get to get rid of all this. Compute. I hope this works. It doesn't work with just two it doesn't work with just two equations. Here. 3a plus 5b. I'm just typing this on my computer. I'm sorry that you guys can't see it. 3a plus 5b equals 0, and a squared plus b squared equals 1. And we are looking for b, I believe. And b is going to be 3 over radical 34. Yeah, so b is 3 over radical 34. That's cool. So we got that. Awesome. And now we solve for a using 3 over. So that was just me checking to make sure I got it right. So I wouldn't waste my time. So by equals 3 over radical 34. And by the way, I believe it could be negative 2, right? Because like the unit vector could be in the downwards direction as well. So yeah, we should just keep that in mind, that like there are two of them. There's one in the positive direction, one in the negative direction. But I'm assuming they mean in the positive direction. Okay, so now we could just plug this in. So we could say bx squared plus 3 over 3 radical 34 over 34 squared equals 1. All right, let's solve this. So first of all, let's simplify. So bx squared plus 9 times 34 over 34. So that will just cancel, right? 34s will cancel. Equals 1. Subtract 9 on both sides. We have bx squared equals minus 9, so that's negative 8. Uh-oh. That's not allowed. We can't have a negative number here. That's not good. Yeah, you can't have square rooting both sides because it will have a square root of a negative. It's not good. No, square root of negative is not a positive. Not possible.
That's what I'm saying.
It's not possible.
Not possible.
Okay. That's weird. What did I do wrong? I didn't do anything wrong.
Well, you did something wrong.
I clearly did not do anything wrong. Is this just a bad equation to plug it in? Yeah. Yeah, I guess this is not a real solution. Fine, so this was the wrong equation to try, I guess. So let's remember that it's 3 radical 34 over 34. That's by. So let's do it in the other one. We have 3bx plus 5 times 3 times radical 34 over 34 equals, and this one was what? 0? 0. Okay. So that's that. Now let's simplify the top, or the whole thing. So 3bx plus 5 times 3 is 15. 15 radical 34. 34 over 34 equals 0. Let's subtract, so 3bx equals negative 15 radical 34 over 34. Okay. So divided by 3, we have bx equals negative 5 radical 34 over 34. Negative 5 radical 34 over 34. Yeah, that is correct. At least the computer also says it's correct, so that's good. It is good. Yep, there you go. That is the answer. Okay, so there you go. That was my second lecture, and a little bit more, problem solving and stuff like that. Hope whoever's watching this enjoyed. I'm going to end the stream now. This was 2 hours. Jesus. Bruh.
Bruh, you be on my desk.
Bruh. Okay.